so question 15 on page 117. A smooth sphere of mass 3 kilograms and velocity u1 collides directly with another smooth sphere of mass 4 kilograms. This one was 3, is it? 4. And velocity u2, both moving in the same direction. Show that, well, we need an expression with v1, u1 and e in it. Okay, and hence show the impulse. Now, I actually didn't tell you what the impulse is, so hopefully you've had the common sense to look back in the chapter, but the impulse is what one sphere, each sphere receives an impulse. The impulse is its change in momentum. So it's the sphere's mass times velocity afterwards, take away its mass times velocity beforehand. Now, because there is overall no change in momentum, then it will always be the case that the impulse imparted to one sphere will be equal and opposite to the impulse imparted to another, so that when you sum together the changes of momentum, you get 0. Okay? Anyhow, to continue with this question then, show that, okay, so we have a u2 and a u1, and we want to show that. Okay, look, again, you might have no idea how you're going to get to that answer in the end, but what I would say you do all the time is you do your standard practice, and in particular in this question. So if we call the velocity afterwards x and the velocity afterwards y, and we're going to use the principle of conservation of momentum, which means 3u1 mass times velocity plus 4u2, that's the momentum beforehand, mass times velocity plus mass times velocity, is equal to the momentum afterwards. Okay, and then we're also going to use Newton's experimental law, which states that x minus y, the difference in velocity afterwards, is equal to minus e times the difference in velocity beforehand. Okay, now what we're going to need to do is we're going to need to get rid of the x and the y's, because we need an expression that only has it has a v1. v1 is the velocity after the collision. Okay, I like calling it x because I get mixed up with all the subscripts, so we're going to stick with x. So wherever we have an x in our answer, we can turn it into a v1. So what are they saying then? They're saying out of this, they need an expression with x, u1, u2, and e in it. So we need to eliminate y. Okay, so we need to get y from one of the equations and then put it into the second one. So if we look at what y is here, okay, so we have, let's see, so up here we have, yeah, that's the easiest way to do it, I think. So 3u1 plus 4u2 minus 3x is equal to 4y. So all of that divided by 4 will give you y. And we're going to put that into the other equation. So we have x minus y, so it's minus 3u1 plus 4u2 minus 3x, x minus y is equal to minus e times u1 minus u2. Okay, we want the expression, so they want it as 7x, so we're going to get x on one side. So we're going to multiply by 4 first, so 4x minus 3u1 plus 4u2 minus 3x. So we've multiplied that by 4 is equal to minus 4e times u1 minus u2. Okay, so we need x on its own, so let's straighten that one out. So it's 4x minus 3u1 minus 4u2 minus, so plus 3x equals minus 4e times u1 minus u2. We can see our 7x now. So 7x, 4x plus 3x is equal to, so we need to bring these over. So on this side, we have to look, I'll do the two steps. Minus 3u1 minus 4u2 is equal to minus 4eu1 plus 4eu2. That's me multiplying out the brackets. So now we have 7x is equal to, if we bring this over, we're going to get a plus 3u1 minus 4eu1, and we're going to get a plus 4u2 minus 4eu2. So let's see what we're supposed to put down. So that's 7x is equal to, they want the u1 outside, so u1 times 3 minus 4e plus, I presume they want the u2, 4u2, yeah, they take out the 4u2 here, so it's 4u2 times 1 minus e. Okay, ooh, I've got a minus and they've got a plus. Where did I get the, oh, that's a plus, sorry. It's a plus from here and it's a plus here. Okay, so that's the first part. Now, the next bit. Hence show that the impulse which each sphere receives. Okay, well, all right. Okay, so the impulse then is just the mass for each sphere is its mass times its velocity, take away its mass afterwards, take away its mass times its velocity beforehand. So the impulse for the first sphere is 3x m times velocity minus 3u1. Okay, so 3x minus 3u1, so basically 7x is that, so x is that over 7. You can see that hopefully. Yeah, x is all of that divided by 7. So we want, the impulse is 3x, so 3 times u1 times 3 minus 4e plus 4u2 times 1 plus e all over 7. And it's 3x minus 3u1, so minus 3u1. Okay, I'm going to rub this bit out now. Don't need it. It's just kind of taking up space. Right. Okay. Now, okay, so we just have to tidy that up. Okay, so let's multiply the 3 in. So it's 3u1, 3 times u1 times 3 minus 4e plus 3 by 4 is 12u2 times 1 plus e over 7. That's me multiplying the 3 in. Minus, now we're going to put this over 7, so multiply by 7 on the top and on the bottom. So minus 21u1 over 7. Okay. So that is 9u1 minus 4, oh, sorry, minus 3 by 4, 12e(u1) plus 12, we leave the u2 times 1 plus e, minus 21u1, all over 7. 9u1 take away 21u1 is minus, that is right, isn't it? It's 9, yeah, minus 12u1. So we've got minus 12u1, when I take that away from that, minus 12e(u1) plus 12u2 times 1 plus e, all over 7. So we'll just tidy that up here. So we can take, let's put the 12u2 times 1 plus e first. And then we have a minus 12u1. And we're going to take that out of both of these. So it's minus 12u1 into 1 plus e, is that right? That gives you minus 12u1 minus 12u1 over 7. And again, now you can factor out the 1 plus e. Of course, I'm just looking at this, but I'm presuming, yeah. So that's, so we can pull out here 12 times 1 plus e. And we can pull the 12 times 1 plus e out of both of them, and then that's times u2 minus u1 all over 7. Okay, good exercise in maths really rather than applied maths.